So now coding the problem as explained. So we have got a class solution define contain duplicate self, and you can take nums so that as it is. Now for I in the range, just try to remember the previous solution. Just there is a link to that. This one is similar to it. Okay, like we are using the for loop there. We are going from I to the length of nums, and there we are going to the next, then to the nums, and we were adding and getting the target. Now we will simply compare it with each other. So like length of nums. Now for j in range, you won't get it anywhere. So developed by me from I plus 1 to the length of nums. If nums of I, you need to understand the approach, what I am doing it. So nums of j, okay. If these two are equal, okay, means the first, if there is a one at the first position and the second position is there is one, if you're comparing, they are equal. So what we will do, we got a duplicate, so we'll return, so to return true, so simply return true. Okay, and if we don't got it, we want to return false also, so we can return false. So this is the very simple approach. There is a brute force approach for it. Simply run it. This is accepted, but when we submit it, so it's still under process. So time limit has been exceeded. That's the problem here. Okay, why this is getting, because the it is going to the order of n square. Okay, order of n square, which is not allowed. So now it is showing the error that is time not exceeded. Okay. So we'll try the another one that I told you, that we will sort the array first, then we'll compare the each first element with the second element. Okay, means the adjacent element we will compare, so we will able to know the duplicates. So doing that solution here for you, the code is here. So take nums, to sort it simply use the function sorted of nums. This is the value for our nums, you have sorted the nums. Now for I in range, from 1 to length of nums. Okay, if nums of I equals to nums of j. Earlier it was equal to j, but here you are taking comparing with the adjacent element. So we can directly compare using the one is I, so another one is I minus 1, the previous one we can compare with it. So we are thinking like if I am on a step, so you can think like means I am going on a step, steps, where I am stepping upwards. So I am on a position up, and I need to compare myself with the before one. So I am comparing with the I minus 1 there. So you can think it like that. Now return true if it is there. Okay, both are equal. Just like previous, just change is there. Now return false. So yeah, this is the solution complete. I think now run it. Yeah, it is accepted. You can see There is no difference. When we submit it, so yeah, it got accepted. Wow. So it is accepting any below order of n square as mentioned. So I think it is of order of n log n. So it is accepting the solution. Now further improving the solution, as I told you, we'll use a set. Yes, the set can consume extra memory at initial level, but it would be very easier solution for us. So let's try using set also. So set we can use it two way. One is we can create a set of the nums which has already been there, or we can start with empty set. So I am starting with the set of nums. Okay, I have created a set of nums. Now let's say we need to take nums also in another array or something. So let's take a set equals to nums. Now if length of the hash underscore set is less than that, I told you that we will find the length and we'll compare both length is less than the length of nums. So what we're going to do, we'll simply return true. Okay, and else it is not, so we'll return false. So yeah, it is working. Now submit it. Yes, it got succeed, and it is faster than 86.16. It's very huge amount, and runtime is also very less. So it's definitely a wonderful solution. Now, if we try using a empty hash set, so how we can approach it? So for empty, we can try it using like, let's take hash set, create an empty set. Now the another approach. Okay, we are creating an empty set. Okay, once you create the empty set, let's try for n in nums. Okay, if the number is in nums, so what we'll do, if we'll check that if this number is in nums and is this number in hash set also. So if the number is in nums and if the number is in hash set. Okay, so what we will do is we'll return true, and so it is a duplicate if it is present both the way. So we'll return true. And if the number is not in hash set, okay, means it is not duplicate. So we'll add it to hash set. So hash set dot add. So hash underscore set dot add, which is added, and for exit condition will return false. So this is also a simple approach. We are starting with the empty set, and earlier we were started with the set of the nums. We are taking extra memory there. Here we are not taking extra memory also, but both the solutions are of order of n times complexity. This one and the previous one. So hash underscore set is not defined. Just a second. This hash underscore set. Run it. There is some type error. Underscore set dot add. Just let me check it. I think it is considered this as set. That's the problem it is getting. So let's try it using, let's do it as head set. Do not take the underscore. Let's try using that. Now run it. takes exactly 0 arguments. So yeah, the problem was means it is okay. You can take hash underscore set at both the location. I just forgot to add the thing that was you are adding. We need to add some numbers, so we need to add the n. Now I think it would work properly. Yeah, you can see that it's accepted and we can submit it. Yeah, now it's the best solution. It is 95% faster than the Python online submissions. So now in the next videos, we're going to discuss another problem. That is problem number third.